Now let's talk about the linear factorization theorem. We use this to find polynomials with the given zeros. So linear factorization theorem says a polynomial function will have the same number of factors as its degree. That's kind of a play on the extension of the fundamental theorem of algebra. And then each factor will be in the form x minus c, where c is a complex number. And again, complex number could be real, could be imaginary, could be the combination thereof. Now, complex conjugate theorem, if a polynomial function f has real coefficients and the complex 0 in the form a plus bi, then the complex conjugate of the 0, a minus bi, is also 0. So the key to this is it has real coefficients. If you know everything's real coefficients and they give you one complex number, its conjugate must be there. And by the way, that they could give you the a minus bi, and then the a plus bi would be there. Again, this is if you have real coefficients. If you have complex coefficients, then all bets are off. But if you have real coefficients and one of the zeros is a complex number, then its conjugate must also be there. And just to reiterate, a plus bi and a minus bi are called complex conjugates because that plus and minus. And just, well, I'm going to leave it at that. Sorry, I can digress quite a bit here. So how to find a polynomial function? If a polynomial function given the zeros and a point c, f of c, use the zeros to construct the linear factors of the polynomial, multiply the linear factors to expand the polynomial, and substitute c, f of c into the function to determine the leading coefficient, and then you can simplify. So we're going to find a fourth degree polynomial with real coefficients that has zeros of negative 3, positive 2, and I. So when it says fourth degree, and they give us 3 of the zeros, one of which is an imaginary number, its conjugate must be there. So we really know that our zeros are going to be, it's x minus negative 3, x minus 2, and x minus 1, and then x plus 1, which is the conjugate of x minus 1. So we know these are the zeros. We'll say a is the leading coefficient. We'll call this f of x. And we can start our fun-filled journey of trying to find this polynomial. And I didn't state the other part. Sorry, I want to make sure that's clear that that's a minus and negative. And they tell us that f of negative 2 is 100. So we can use that to find, once we have our polynomial, to find out what the leading coefficient is going to be. Okay, so I'm going to rewrite this a little bit as f of x is a times x minus negative 3 is x plus 3 times x minus 2. And then this x minus I times x plus I, that's a complex conjugate. So I'm going to multiply those out. And that's going to be x squared plus ix minus I squared. And yes, these middle terms will go away. And so you might be saying, well, can't you just do it as x squared plus 1 squared? And you're right if you see that much. But if you're not there yet, that's okay. So f of x equals a times, I'll multiply this out. So we have x times x is x squared minus 2x plus 3x minus 6. Then we have x squared minus, and I squared is negative 1. So f of x is a times x squared plus x minus 6 times x squared plus 1. And that would be a times x squared is x to the 4th. X squared times 1 is x squared. X times x squared is x cubed. X times 1 is x. Negative 6 times x squared is minus 6x squared. And minus 6 times 1 is minus 6. So f of x is a times, we have our x to the 4th, then we have an x cubed, then we have our x squared minus 6x squared, so minus 5x squared. And then we have a plus x and then a minus 6. Okay. So now we also know that f of negative 2 is 100. So, and by the way, we could have plugged this in earlier. Maybe it would have been easier, maybe not. I don't think it would have been with the complex numbers there. So I wanted to do it this way. F of negative 2 is a times negative 2 to the 4th power plus negative 2 cubed minus 5 times negative 2 squared plus negative 2 minus 6. And that's going to be a times, let me get my calculator out here and see what that's going to be. And I get negative 20. And that is supposed to equal 100. So if I divide both sides by negative 20, a must be negative 5. So our function can be written as f of x now is going to be negative 5, and going back to the x instead of that 2, negative 5 times our x to the 4th plus x cubed minus 5x squared plus x minus 6. So it's negative 5x to the 4th minus 5x cubed plus 25x squared minus 5x plus 30. And this would be our polynomial. Okay, that was a lot of fun. And next we get to talk about Descartes' rule of signs.